home. That's what this topic is. How the wiring is done in our home is all about domestic circuits. So why it is called as domestic circuits? Because the wiring done in the commercial places is not same. If you go to factories, industries, the way the current supply or the wiring is done for the factories or industries is not same as that done in your home. Okay? There is a different wiring done for the factory side and different wiring done for the domestic homes, general homes. So what is the difference between that? Let me not go into the difference much. First I will talk about domestic circuits much. So domestic circuits, if you see, first is when the current is coming to your home, current in the sense the supply, the power supply from the government, it comes to your home, it first comes to the main board, right? It comes to the main board. Main board is the place, down it is there, no? Don't touch there anytime. In that main board we have fuse, many fuses are there. We have a meter, electrical meter. Aware about that? Meter is there, fuse is there, and many trips are there, open, down, these things are there. Have you seen that point? Seen? Yeah, down it is there, man. So that is called as the main board. Main board is the point where the current comes to your home. Okay? Most dangerous place actually, because the whole power that comes is entering from here only. And here the electric meter is there, right? This will always be in series because it is the meter which will measure how much power you are consuming. It should not be in parallel. If it is in parallel, it will consume only partial. So it must be in series. So electric meter and the fuse must be in what? Series. I am talking about the main fuse. If you take this out, current will go in your home. Don't pay the bill, they will take it. People from TNEB will come, they will take that and go. Have you seen that happening? It happens. Forget to pay the bill. They will come down, they will take out that thing and they will go and sit in the Perangalatur bridge. You have to go fight with them and get it back, or pay the bill and get it back. Okay, whatever. So fuse is that point where the current enters, and why fuse is there? Excess current comes, it has to melt. Why it will melt? It will have low melting point and it will have high resistance. Okay. One second. Revan sir, am I live? Am I live? I am live, no? Thank you. Yes. So fuse should have low melting point and high resistance. Why high resistance? Because the current should slowly pass through it. Why the current should slowly pass through it? Then only current will be felt by the wire. If extra current is there, it will melt. See, resistance I have told you, it is not about stopping the current. It is not about reducing the current. It is all about slowing the current. More resistance, current will pass very slowly through it. And why we want the current to pass slowly through it? Because the wire has to melt. It needs some time for melting if the current is excess. So since it has low melting point, it will melt immediately if the current is excess. And it will save the whole home from excess of current coming inside. Okay, this is fuse. Now the current comes inside to your home. What we will do here, we will separate two lines generally. Not in all the homes they will do, but they do nowadays in all the homes. Earlier days we don't do this. We will make two wires, two supplies. One will become 5 ampere line, another will be 15 ampere line. Nowadays we also have 10 ampere, 20 ampere. It is just because in some places we want to use thin wires, in some places we want to use thick wires. Otherwise, give your whole home 15 ampere you can give, but the whole home will require thick wires. Costly? Wire cost is depending upon its diameter. I hope you know that. You go and buy, you will tell. They will say inch, in inch they will say, and they will charge you based upon thickness, not based upon length obviously, but thickness also they will charge. A thin wire and thick wire will not be of same rate. Thick wire will be because more copper is there inside. So 5 ampere line will have thin wires. Remember this thing also, basic thing. Why thin wires? Because it has less current. Let it be having thin wires because it will not melt so easily. The problem is if you pass more current in thin wire, it will melt because of heating effect of electric current. So we maintain thick wires in the case of higher current and thin wires in the case of what? Lower current. Now 5 ampere line, whatever you are going to connect, everything should be in parallel. That is, all the connections in home will be in parallel. I hope you know this, all of you know this. Why we should have parallel connection? There are two reasons for that. Both reasons are important. One reason is obviously, which you will know, that one device stops working, other device must work, true. If it is in series, one device stops working, everything will stop working. If it is in parallel, one thing stops working, other will not get affected, isn't it? Suppose here one bulb is there, this bulb got fused. This is a symbol of bulb, those who don't know. This is also a symbol of bulb, but apart from that, this is also a symbol of bulb. If this lamp gets fused in the case of parallel connection, only this branch will get affected, this branch will still get current. Are you getting my point? But if I would have put one bulb here, one motor here, one fan here, and all these things, if this stops working, this also will not work, isn't it? First reason, very basic reason. Second reason why we should have parallel connection is, every device that we have in our home is designed to work at 220 volt potential. And if you know, in parallel connection, the potential difference across each apparatus will be same. Do you know this? Do you know this? If you connect a battery here, source of potential difference, then this battery, if suppose it is giving 10 volts of potential difference, here also 10 volt will be there, and here also 10 volt will be there, right? But I would have had two resistance, and if I connect 10 volt like this, that is the battery, then it will get some maybe 3, it may get 7, or 10, 0, or 4, 6, whatever. We don't want the potential difference to get splitted, because each device wants to work at 220 volt only. If you are going to give series connection, 220 will be split up 10, 10, 10, 5, 6, nothing will work. Or if it works also, it will burn immediately, because low voltage will lead to more current grasping. More current grasping will lead to tremendous heating effect. There will be a fire accident. So we should not have series connection inside when the power came inside. Are you getting a point? Up to fuse series only. But after this, when the current comes one wire, this also will have parallel connection only. All the components will have 15 ampere, everything will have parallel connection. Because 15 ampere and how much volt? For India, 220 volt, isn't it? 15 ampere, 220 volt, 5 ampere, 220 volt. These both lines will come inside. Now, these both lines also will have 3 types of wires coming inside. One is called as, earth is last. Okay, first you want to speak earth. Earth wire, live wire, neutral wire. I have told you already that neutral wire will be what in color? Black in color, earth green, and live red. This was single phase. Nowadays we have multi phase. You may see in my home I have seen blue wire, I have seen yellow wire. You may see like that. In my home, they are not using color coding. I am seeing yellow wire, blue wire. Why are they doing like that? Because now we have 3-phase current. If 3-phase current comes, what is the meaning of 3-phase? You know, there should be 3 live wires. Earlier, now also in many homes, when you go and get an electric connection from the government, they will ask you single phase, 3-phase. Single phase will be cheap, only 1 live wire they will give you. I am talking about the bribe. And then multiple phase, that is 3-phase, will be costly. They will charge more for that. But 3-phase, if you get in your home, sometimes 1-phase line will not be there, other phase line will be there. I have seen in home they will do turn that. Current not coming, turn it, it will come. Because sometimes power is there in one line, not there in another line. Take use of that. Are you getting my point? So they are giving 3-phase for that. So 3-phase will have multiple colors, that is red, green, not green actually, yellow and blue. 3-phase it means. Otherwise if you have only 3 colors, single phase. Now you may ask, sir, why black? I will use red hair, I will use black hair. Any problem? No problem. But when there is somebody coming for repair, he should not think this as live, this as neutral. He will touch it, gone. That's why we are giving this color coding itself. Color coding is given for you to understand that it is having live, it is having that current. Don't touch it. Are you understanding my point? Because if you touch neutral wire, put in mouse also no problem. Because it is not having it, don't do that. But it is neutral. Neutral means zero potential difference. But live wire is dangerous. It has 220 volt line. Somebody can ask, sir, what if I connect earth and live? Will it work? It will work. Because earth is also zero potential, infinite potential actually. We want to create potential difference. The moment potential difference is created, current will flow. So this earth or live also will create, we will never do that, but and live and neutral will also create, right? So these three lines will be going from this also, from this also. That is 5 ampere line, we will have earth, live, neutral. 15 ampere line, we will have earth, live, neutral, and again difference will be here thick wires, here thin wires. Why thick wires? Because more current. Why thin wires? Because less current.
Sir, what if we connect the earth and neutral?
Nothing will happen. Because earth will not carry any voltage, neutral will be also 0 volt, so no volt potential difference created. We want potential difference for any problem. Problem is current to flow. If there is no potential difference, no current will flow. Are you getting? So live is the main thing. If live is not there, no problem. But live is not there, no current also. Okay. So is it clear to you? This is how a domestic supply is made in the home. So in your home, the current comes from the supply to the main board. There you have meter where they will measure the reading of how much power you are consuming. Fuses will be there for saving your devices from any kind of short circuiting or overloading. And then it comes to your home, 5 ampere line, 15 ampere line, both will be having parallel connections. I hope it is clear. Next thing is, in this topic itself, we have two more things, short circuiting and overloading. Questions are coming from there frequently. So short circuiting is the point where live and neutral directly touch each other. Why it is called a short circuit? Because in a circuit, whenever we draw a circuit, you would have seen that we make some resistance and then only we connect like this, isn't it? Have you ever seen a circuit like this? You have never seen. If somebody is making, it is wrong. At least one resistance is required in a circuit. Because resistance is there, it is a kind of load. If load is not there in a circuit, then what will happen, you know? There will be tremendous increase in the current, sudden increase in current, and at sudden increase in current will lead to overloading of current, which will once again cause heating effect of electric current, fire accidents will happen. So if live and neutral come in direct contact with each other, there is going to be sudden surge of current, and a sudden surge of current will bring it with itself heating effect also, and heating effect will create fire accidents. Wire will melt, fire may also take place. So this can happen because of two reasons. One reason is wire has become naked, maybe because of some chiseling or some person standing the wire or wear and tear with time, and two wires became naked and they touched each other, gone. When they touched each other, live neutral touched, short circuit. Second way, it may also happen like you are throwing water in this. Take 1 glass of water, throw on the socket. What will happen? Water is a good conductor. For a 1 second also, if water goes in both live and neutral together, it will complete the circuit. Circuit becomes completed, no resistance, 1 second short circuit. That's why we avoid damping of the circuits. Have you seen it? If damping is there, it should not happen near the points. It is risky because dampness means water, and water is a good conductor. It will complete circuit and definitely it will create problem. Another thing is about earth wires. Earth wire is for taking excess current back to the earth or giving a short path to the current to go inside the earth. Usually earth points are there in heavy appliances and in metal body appliances. Fridge, even if we have low power fridge body is made up of metal, right? It will have an earth point always. You will not find any fridge without earth point. Mobiles will not have earth point. Mobile means charger of mobile. Laptop charger may not have earth point, may not. Even TV nowadays will not have earth points. See above, any earth point is there for this TV. Above only point will be there. I don't think, only 2 points will be there. Because these are not having more power, one thing, and body is almost of plastic nowadays, isn't it? But same TV, if it would have been of full metal body, they will give earth point. Because metal body is there, metal is a good conductor, little bit of leak of current will make the current to fully come in the TV itself or in the device itself, and you will get some shock. Sometimes you would have felt this also in fridges, touching sometimes gives some shock. I don't know how many of you have felt in real life. I have felt in my childhood. If earthing will not work properly sometimes, no, because charge is there, metal body is there, it will distribute on the whole body, it will become charged. So earth will help in taking the current back to the earth. Understanding this? So where do we use earth points? We use mostly for high power appliances, heavy power appliances. Second, where do we use? Wherever the metal body is there of the device. Like electric kettle will always have third earth point. Have you seen electric kettle used to boil the water or making tea, anything? Why it will have earth point? Metal body. Metal body, or you using water inside that. Double risk. So always give earth point for these things. Will have mostly. Washing machine is because of high power, and nowadays washing machine is not metallic body, plastic only they are making. Inside the drum is the metal, but we don't touch that drum directly when it is operating. Otherwise you can touch, no problem. So I hope it is clear. Domestic circuit, you only asked, man. Clear? Any doubt is there in domestic circuit? You want to ask any question on domestic circuit? One more thing I want to say you, overloading. Sometimes overloading may also take place. One way is by short circuiting. Another way is one point is there. Suppose that point is there down. In that point, I keep a multi-pin. You know what is multi-pin? It will make one point to multiple points. It will have like one thing like up, down, or you put junction box. That is also better. In that junction box, I have 6 points. It is called a spike buster. Those who know little bit marketing terms. Spike buster, not know? Okay, spike buster or extension cord. In that there are 6 points. 1 point I am putting laptop, 1 point I am putting heater, 1 point I am putting geyser, 1 point I am putting fridge, 1 point I am putting electric heater.
Fire, sir.
Why fire?
In the house.
Why when fire in the house?
Overload.
Overloading. Because there are so many power devices, every device will require current from that 15 ampere, it may be 15 ampere point itself. You are trying to draw 50 ampere or 60 ampere. What will happen? Surge of current, overloading of current, heating of wire, melting of wire, fire accidents. Are you getting? So overloading can happen by 2 ways. One way is by short circuiting, sudden increase in the current. Second way is by overloading of a particular point. You may have multiple connections in one point. All appliance will draw more current. All appliance drawing more current will cause heating effect of current to melt the wire. Clear? So how this circuit is made? You are clear, Ashwath? Anybody has doubt from online, or shall I go to the next topic? If all of you are okay in this, I'll go to the next topic. Yes, please. Where means in the sense? See. Suppose in this room, let us imagine. From outside the wire has come. These boxes you are seeing, we have made it. If you open inside, wires will be going. Okay? So when from the main the lines are coming, 3 wires will be coming. This is all here in this room are 15 ampere points only. We don't have 20 ampere actually. All the points are 20 ampere points. There are 3 wires coming, green in color, red in color, and black in color. So when it is coming like this, wherever we have points, no, they will connect. In one point they will connect green, one point they will connect red, one black, and they will continue connecting. Are you understanding? But they will connect in parallel connection, not in series connection. Once again, why a series connection? If we connect, one thing will go, other things will also not work. So in switch box also we will do parallel. Are you getting my point? So wires will be coming and it will be keep on connecting with the switch points. Then it will go this side, some other point is there, here also they will connect. The whole home the same wire will run. Understanding? Anything else you want to ask online people? Anything? If topic is clear, then I'll go to the next topic. Shall I? Somebody asked, domestic circuit done. Somebody asked heating effect of electric current. That is simple topic, but let me talk about it. So, heat is a kind of energy, right? I hope you know heat is energy. Different forms of energy, one of the form is heat. Now this heat, any energy is always equal to work done, you know this? Energy is always what? Work done by time. That is power, Thambi. I am talking energy, not power. Power, as you said, yes, work done by time. Did I ask power? You are thinking power and energy are same. Bad. Power only is work done by time. Don't confuse. I have seen many children confusing in this. Power and energy are not same. Okay, Ashwath? Power is rate of doing work, as you said. Work done by time is power. In 9th as well as in 10th. And energy is capability of doing work, capacity of doing work, which is actually in joules only. Energy is measured in what? Watts, huh? Joules only, no? What is joule? Work done only, no? So energy mathematically is equal to work done. Conceptually, it is the amount of work, capability of work done, capacity of work done. Okay. So energy, if you want to find, you have to multiply power with time, isn't it? Yes or no? So when I want to find heat energy, what I will do? I will multiply electrical power with time. What is the power formula? Vi and Vi into T. This gives me the heat energy. Are you getting my point? One more thing I will say you. So what is V? V is IR. So I into R into I, it will become I square RT, or I is equal to V by R. So I can write H also is equal to V square by R into T. Now you may have a doubt. I have three formula of H which has to be used. They are not same. Here the current is proportional to square. Here the current is proportional to the just I. Here H and R are directly proportional. Here H and R are inversely proportional. What has to be used? Whether this formula or this formula. If the question comes, there are two bulbs, 50 watt or 50 ohms, 100 ohms. Which will consume more heat or which will produce more heat? What will be your answer? 50 watt bulb, 100 watt bulb. Okay? Which, you know that bulb, if it is used, it will become hot. Whether 50 watt bulb or 100 watt bulb, which will become more hotter? Ohms, sorry, ohms. 50 ohms bulb, one is 50 ohms bulb, another one is 100 ohm bulbs. Because you are using this formula, right? I square RT. Why did you use that formula? Here it is inversely proportional. Any answer? Anybody online also can answer. Question open to everybody.
Sir, if resistance increases, heating effect will increase.
Who told like that, man?
Because resistance and heat are directly proportional.
This formula is wrong. Is it directly proportional, Ashwath? Then? Current? If I ask you like this, what will be your answer? Your answer should be, it depends upon the connection of bulb. See, understand one thing, please pay attention. H is proportional to R. Everybody please pay attention. H is proportional to R if current and time are constant. Am I right? Yes or no? If you are writing A is equal to 60B and you are writing A is proportional to B, you can write if 60 is constant, isn't it? If 60 is a variable, you cannot write like that. So since I and T are constant, when I and T are constant, then only H is proportional to R. Same way here, what you can write? H is inversely proportional to R if V and T are constant. Variable. Constant. Now, I'll tell you, don't confuse much. In which case current is constant? No case we can make from this here. I told no, we cannot comment on this until you are telling whether these are in series connection or parallel connection. Because if you have resistance in series, current remains same, right? 5 ampere, 5 ampere, 5 ampere, 5, 5 will become 4 or 2. No, right? Current remains, but potential difference differs because of resistance. If this is R2 is more, it will have more potential drop. R3 is maximum, it will have maximum potential drop. So V1, V2, V3 is totally depending upon resistances. So in the case of series connection, potential is a variable, but current is a constant. So if these bulbs are in series connection, then 100 ohm bulb will have more heating effect. Are you able to understand this? If these two bulbs are in series connection, this bulb will have more heat energy produced. At the same time, there is a possibility that we have parallel connections. What happens in this case? If circuits are in parallel, what remains same? Potential remains same, and the current gets splitted, I1 and I2. So now V becomes constant. If V is constant, H is inversely proportional to R. It means if two bulbs, 50 ohm, 100 ohm, are in parallel connection, then 50 ohm bulb will have more heating effect, 100 will have less heating effect. Individual level, if you find 50 separately, 100 separately, then it depends upon how much current is coming inside. Because H is equal to I square RT, how much current is coming, how much time it is coming, multiply and get the answer. But if these two bulbs are connected together, and if they are connected in series like this, let this be bulb 1, bulb 2, then bulb 2 will have more heat produced compared to bulb 1. If the bulbs are connected like this, bulb 1 will have more heat energy produced compared to bulb 2. Okay? Is it fine? I hope it is fine. So this H is equal to I square RT is only called as Joule's law of heating. Why it is called as Joule's law of heating? Because Mr. Joule found it. And how did he find it? He made an instrument called as calorimeter, and in calorimeter he had resistance, he passed current for a particular time and measured how much heat energy is produced. First what he did, he kept resistance constant, kept on changing the current for a constant time, and found relation that when the current is increasing, heat also is increasing, square to it. So he wrote H is proportional to I square. Then he kept current constant, time constant, used 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm. Then he saw that as the R is increasing, H is proportionally increasing. He wrote H proportional to R when I and T are constant. And then he kept T as a variable, I and R are constant. And then he found H is proportional to T. Then he framed this equation, H is equal to I square RT. That is one way of writing. Another way is this formula, power into time. Is it clear? This is called as Joule's law of heating, where H is equal to I square RT, H is equal to VIT, or H is equal to V square by R into T. And whether H is proportional to R or inversely proportional to R is a question of connection, series or parallel. It is not an absolute answer. You cannot say that absolutely it is proportional. No. It can be proportional, it can even be inversely proportional. Is it clear to everybody? Any doubt? Sure? Anybody in online want to ask something, or shall I go to the next topic? If you permit me, I'll go to the next topic. Shall I? Nothing is coming, so I am assuming you are understanding. Okay. So next, this topic also done. Then comes some left-hand rule and questions regarding circular current carrying loop. So first I'll go do this, then I'll go to that. So circular current carrying loop. First of all, understand what is the meaning of it. So if you have circular current carrying loop like this, I have not drawn oval shape, I have drawn circular loop in this direction. Which direction? Like this. How I'll draw on the board? I have drawn like this. Or if you are confused, let's draw like this. This is circle like this, right? If I draw circle like this, how I'll draw on the board? That's why I've drawn like this. Okay? Understand it, both are circles only. So if you have a circular current carrying loop, then how is the magnetic field produced? It was found by Mr. Oersted in his experiments. The two people behind this were Biot and Savart. You will learn in higher classes. What they did, they took a cardboard, very basic experiment, and they made this circular current carrying loop to pass through it. Cardboard, loop is passing, down it is coming, connect through what? Some battery. What will happen now? Current will flow in this direction, isn't it? So for this part, the current is going upwards. For this part, current is going downwards. Now you know right hand thumb rule. It says that if thumb is giving direction of current, then four fingers give direction of magnetic field, right? So if the current is going upwards, and if I draw the magnetic field direction, then I am going to get magnetic field direction as anti-clockwise. Can I say like that? Can I say like that or not? Upwards, so anti-clockwise. So anti-clockwise in the sense it will be like this. Do you agree with me? Same way, here the current is going inwards. It will be clockwise. Feeling that? So here it was anti-clockwise, here, but see they are coinciding in the middle like this. So what is coming? It is coming like anti-clockwise, clockwise, and like parallel straight lines in the center for one loop. Multiple loops if you connect, it will become like a solenoid. But before going to that, so what we came to know, that if you have a circular current carrying conductor like this, I will draw a three-dimensional diagram for you. Understand more clearly. You know how will the magnetic field be? If it is taking like this, the current is going in this direction, then it will have the magnetic field lines like this. Are you able to feel how the magnetic field lines are? That is how it will look like from outside. So circular loops, obviously it will form loops only here. And it will be like this. Are you feeling the shape of magnetic field lines? Trying to enter and go like this. That is the shape of magnetic field produced by a circular current carrying conductor. So I will repeat this for you. Circular current conductor is like this, and if the current is going in this direction, like how I have drawn. See, once again, clockwise, anti-clockwise is a very controversial topic. Why I am saying controversial topic? Controversial is not a confusing topic, because now this I am doing, no, it look what to you? Clockwise. Clockwise for you. But for me it is? So it changes by the frame of reference. For me it becomes clockwise, for you it becomes anti-clockwise. So always this, to some people it look, some people who are seeing this board, no, they will say it is clockwise. Some will say it is anti-clockwise also. Some will say it is anti-clockwise, sir. They will think this is inside, this is outside. Check, think, it look like this and like this. So anti-clockwise. And somebody will say like this, anti-clockwise. Both way we can say. People seeing from this side, it will have a different view. Seeing like this, it will have a different view.
Sorry, could you say that again?
Are you getting my point? So, always remember, the magnetic field, because of circular current carrying loop, will have this kind of shape. One more thing I will say, that this magnetic field is depending upon some things. It depends upon the current, obviously. More stronger the current is, more stronger the magnetic field is. It depends upon the radius of the loop. It is inversely proportional actually. I should not write like this. Yes. So, if you have a loop which has a smaller radius, suppose I have two loops, it has a current of 2 ampere, it has a current of 20 ampere, check here and check here. So, both are 20 ampere, same current at the center. This will have a stronger magnetic field. If it is B1 and if it is B2, then B1 will be more than B2, because magnetic field is inversely proportional to the radius of the circle. A smaller radius will have a greater magnetic field, a greater radius will have a smaller magnetic field. Understanding this? This is one part. Another thing is, it also depends upon the current. So, if there are two loops having same radius, but one loop is having current of 10 ampere, one is having current of 30 ampere, then this loop will have a stronger magnetic field, B2, B1, B2 will be more than B1. Understanding? That is the basic difference between the loops of different shapes, that is different radius and different currents. Now, usually in the examination from here, the questions, if you see the questions that come from this topic, are mainly to talk theoretically about this experiment, draw the magnetic field lines shape, and some questions like this sometimes comes. Two loops they will draw and they will ask which loop is having more current, more magnetic field. They may do like this, same size and different currents, simply you can say. This can be sometimes confusing for you, so remember this. So, smaller loop will have a greater magnetic field if the current is same. So, both having same current, smaller radius, bigger radius, this radius will have a bigger value of magnetic field. Is it clear? Very basic thing I am talking. Then somebody has asked to talk about Fleming's left hand rule. You asked, no? Fleming's left hand rule. So, Fleming's left hand rule is used for which device? Electric motors. So, electric motors is not there in syllabus or there? I think it is not there in syllabus, right? But it is also used for finding the direction of force, isn't it? In a current carrying conductor kept in magnetic field. In current carrying conductor kept in magnetic field. So, if you have a current carrying conductor which is kept in magnetic field, it will experience a force. Remember that the current carrying conductor is going to produce a magnetic field. That's what you learned in this chapter itself. Full chapter what you are learning, if a wire is there having a current, it will have magnetic field around it. So, current carrying conductor has a magnetic field, magnet will have a magnetic field. Two magnetic fields are interacting, force will definitely act. If you have one magnet, another magnet, bring it close, what will happen? Either repelling or attraction, something will happen. It is not possible that nothing happens. Either attraction will happen or repulsion will happen. Why? Because two magnetic fields are interacting, force starts acting on it. Same thing happens here. If you have a current carrying, suppose I am having a conductor, assuming it is carrying some current because of some connection of battery, let us assume it is having current, so this direction current is going, right? And this current carrying conductor is placed in some magnetic field. Let the magnetic field be like this. When I am drawing this, what is the meaning of this? You know, into the plane. I have taught this to you. This is called as into the plane. Into the plane means magnetic field is going like this, from you towards the board like this, right? Now, it was observed that this conductor will start having some motion, movement. Which direction? That is found by using Fleming's left hand rule. So, Fleming's left hand rule says that if first finger is giving direction of magnetic field, middle finger is giving direction of current, then thumb will give direction of force. So, see here, magnetic field and current, my thumb is pointing downwards. So, automatically this rod will be attracted towards downward direction. If it is allowed to move, it starts moving down. Are you getting why? Because Fleming's left hand rule says that if you extend your first finger, middle finger and thumb mutually perpendicular to each other in such a way that first finger is giving direction of magnetic field, middle finger is giving direction of current, then thumb will give direction of force on the current carrying conductor. It is not only applicable on the conductors, it is also applicable on the charges. It means that same magnetic field, suppose I am having into the plane magnetic field, and in this into the plane magnetic field, suppose a charge enters, suppose a positive charge enters like this. If a positive charge is entering, then you should know that direction of current and direction of positive charge is always same. That is called as conventional current. Aware about that? If positive charge moves in this direction, current will have in the same direction. So this charge will create current in this direction. Now current direction is known to you. Your magnetic field is known to you. Thumb is pointing upwards. So this charge will start moving like this, deflected like this, isn't it? I told this already to you. It may not go straight because once again direction of current has changed. Magnetic field inside, current upwards, thumb towards left. So this charge, instead of going straight, it will take a turn and go like this. Will it be able to go like this? No, because once again current direction has changed. Magnetic field into the plane, current is towards left, then thumb is pointing towards down. So it will take a turn and come like this. Will it be able to go down like this? No, because once again magnetic field, current down towards right, it will push like this. So this charge will come in circular motion. So in this room, if I am having a magnetic field from you towards me, like this magnetic field is there, and a charge enters, plus charge enters like this, it will come inside, it will keep on undergoing circular motion. Are you understanding? Why? Because of Fleming's left hand rule. Direction I am finding. And the force, how much it will be, those things we learn in higher classes. But understanding? So the question will come, I have already told in the previous class when I taught this, that when you are sitting in a chair, suppose I am sitting here on a chair or I am standing, and there is a magnetic field in front of me from left to right. You can assume you are left to right also. I am sitting on a chair, you are all sitting on a chair. Magnetic field is from where to where? From your left to your right. Direction of magnetic field. A negative charge is moving from top to bottom. So electron is moving from top to bottom, for you also top to bottom. Now negative charge moving from top to bottom, current will come from bottom to top. Put your hands properly. So current upwards and the magnetic field towards my right. My thumb is pointing away from me. Check that, you will also get, if you use properly. Ashwath, well, you have 3 fingers, right? 2 fingers only you have. Why are you doing like this then? Man, mutually perpendicular, man. Mutually perpendicular. Not able to move. Now properly put, no. Magnetic field direction, current direction, upwards. Why are you doing like this, man? They're not dancing, man. Properly put your finger in direction, left to right, right? Put your first finger left to right. After class, I will bend your fingers. Okay, I'll come to you. Others are understanding? So this first finger is going towards my right, for you also towards your right. Middle finger is going upwards. My thumb is going away from me. It means that this charge, which was going from top to bottom, how it will go, you see? It will come like this, it will move like this. Are you feeling how it will move? So answer is, the electron will move away from me. Options will be there. Away from you, towards your right, towards your left. Away from me. Are you getting how away from me came? I hope you are understanding this. Like that questions will come. One question I have seen in the board examination where they have asked, a person is sitting on the chair and the magnetic field is from his behind to his front. Magnetic field is from behind to front. A charge is moving from his left to right. Charge is moving from left to right, positive charge. And magnetic field is from behind to front. So this is the magnetic field direction. Charge from left to right, thumb upwards, right? Thumb upwards means this charge you are trying to move from left to right will come like this and go above. Are you getting how it will deflect? It will get deflected. That is what this kind of questions are coming in the exam also. Fine. So I hope this is also clear to you. Left hand rule is clear, Mr. Ashwath? Your fingers need to be repaired. Then only it will work properly. Fine. So after this, one topic was remaining refractive index. Already I'm running out of time. I have students waiting for me. So we'll meet again in next session whenever Wednesday I'll come again. That time I'll continue discussion and I'll bring questions. Ashmita, I'll bring if she's there. I don't know. She left. Huh? Republic Day is on Sunday, Thambi. He is having his own calendar. Okay. Bye bye. Take care. Online people can drop. Take care. Bye bye. Republic Day is 26 January. We are keeping our